Welcome to EDU World Space.
We'll be looking at how to locate a force acting in a Cartesian system. Now, let's say we have a force F, and that force is equal to 6I minus 2J plus 1K. Kilonewton. Now, and this force is causing a moment. Okay, it's causing a moment at O, about O, and the moment is given as 4I plus 5J minus 14K. Now, kilonewton, this is kilonewton meter. Now, we know for the x coordinate, we know that that along x, it is 1 meter along x where the force is acting, but for the other ones, we don't know. So, for y, don't know, and for z, we don't know. So, what we can do, since we know the moment, we'll multiply the moment by the position vector and use matrix, in fact, determinant in matrix to solve for to get the other parameters y and z. Okay? We will arrive at some equations which we will solve, some linear equations, and solve them to get their values, so that we are going to have our moment. So it's something like this: moment is equal to the position vector. So let's call it OA. Okay. Times the force. Okay, and the force is already given to us. So when we do that, we are going to have our moment. Of course, our moment is 4I plus 5J minus 14K. So we can now multiply the other ones, form our matrix. We are going to have it to be I. Okay. Sorry. IJ K. So under it, we put for our position, we know along the x-axis is 1, but we don't know for y, z. Y for the force is already given as 6 minus 2. So these are the dimensions, 1. All right, all the values. So when we solve for this one, we use determinant method to solve for this one. We're going to arrive at some equations. 4 is equal to y plus 2z. Okay, we call that equation 1. We have another equation 5 is equal to minus 1 minus 6 minus 6z. You can call this equation 2. Okay, call this equation 2. Then we have the third equation. We have another equation. So that one is minus 14 minus 14 is equal to minus 2 minus 6y. So that's our equation 3. When you solve this, so you can try all these one, try the determinant to get your equations, and you're going to arrive at y to be equal to 2 meters and your z to be equal to 1 meter. So it's 1 meter high, 2 meters along the y-axis, and 1 meter along the x-axis. So this is 2, 1,